my name is Gabriel. I'm a software engineer at Airbnb. I work on Android. I also do React Native infrastructure, and I made this thing called Lottie, which is what we're going to talk about today. And if you all have an Android phone, which I imagine many of you do, there will actually be a live demo. Live demos pretty much never work, but we're going to try. So if you download the Lottie app from the Play Store, it's the one that looks like that. Just go ahead and download it, and then we'll get to build an animation together, and you'll actually get to see it on your phones, if it works. So let's do that. So just go ahead, download it, and then I'll continue. So if you're not actually familiar with Lottie, I don't know what you're doing here, but I will explain it. It's basically, there are three parts to it. There's Adobe After Effects, which is software for designers. There's Body Movin', which exports those animations as JSON, and then there's Lottie, which takes that JSON and then it renders it on Android, iOS, React Native, and web. So After Effects, if you're not familiar with it, it's because it's mainly made for designers. It's in the Adobe Creative Cloud suite of software. So if you've used Photoshop, Photoshop is really good for editing images and photos. Well, After Effects is the same thing for videos and animations. It's actually used, there are kind of two different sides of it. So there's the video effects, special effects for videographers making films and movies and TV shows. We'll often use it for things like that, but it's been adopted by the software industry to do vector graphics and motion graphics. And but prior to Lottie, there was never any way to actually get those into your app. So this guy named Hernan Teresi came along, and he wrote a plugin called Body Movin', which basically takes all the vector information from an After Effects animation, exports it as JSON, and then he wrote a web player that can actually render that JSON in a website. And so this actually came before Lottie. It's about 2 years old now, and it's a really fully featured web player for After Effects. And then that's where we came along, and we decided to take that same JSON and then export it, and then render it natively for Android, iOS, and React Native. And so Lottie is built for you guys, the engineers, and if it does its job correctly, it should just work. So the goal is to be able to consume these animations just like you would normally consume like an asset or a PNG that you get from a designer. It's sort of a strange name, Lottie. You've probably never heard of it before, because it's actually named after this woman, Charlotte Reiniger, who is basically the pioneer of the entire animation industry. She started her first animations all the way back in 1919. This is like a decade before Snow White. And she was really the first person to ever create these films that recorded things that weren't real. It's not an actual recording of people or things in the real world. And it's actually quite amazing. You can go on YouTube, you can see her work. It's really remarkable how well her work is aged. So before we go into the details of how Lottie works, let's take a look at what it can do. So here are a few examples. These are actually 3 animations taken from the internet. So one of which is Nick Butcher, who's here today, who they went and they took an animation, and it required so much work to create that animation that it was actually worth writing an entire blog post of how to recreate that animation for mobile. So there are 3 examples here. We took these 3 animations and we threw them together really quickly in After Effects, hit export, and then they rendered on Android and iOS with no additional code necessary. But since we open sourced it about 6 months ago, a lot of other companies have started to use it as well, even for things that we never considered before. So walkthroughs have been very popular. So here's an example with Walgreens, where they're using it to show prescriptions and photos and different features within the app. One of the reasons why Lottie's particularly good for things like walkthroughs is because instead of just hitting play, you can actually tie the progress to a scroll position. So as the user scrubs forward and backwards through these pages, you can actually interact with the animation, and it will actually be tied to the actual scroll position. Target is another example. They're using it for kind of a similar walkthrough, as well as Raise Me. And so these include text and layers and mats and masks, and we'll get into some of the details of like the composition of some of these animations. But there's a variety of different effects you can achieve, and as long as you can put them all together, and again, if you use the supported feature set of Lottie, it'll just work. People also use it for animated icons. So here's an example where what would normally have been a static asset before is now a little bit more playful. Things can move and bounce around or spin. This clock is actually the first use that we had in the Airbnb app. So inline in search results, instead of showing something just like a picture of a clock to show that there are not many listings left, it'll spin, and it's just a little bit more fun and playful. We recently did a partnership with the Noun Project where we animated modern pictography, which is a set of icons in the Noun Project, which are available. You can go and actually download them and use them if you want. And then there's like 30 or 50 of them in this set. And then some people use them for animated illustrations. So here's Instacart, for example. And then something similar that we did in our own app. And again, these are things you could have done before with an animated GIF or a video or something like that. But the file sizes for a Lottie animation are like 10 times smaller. They scale up. They'll never be pixelated. And then you can use the same asset between Android and iOS. You can also use it to animate the logo for your company. So you can have it come in if you have a splash screen or something like that. Here's SwiftKeys. Pillow recently started using Lottie for their animation. And it was also a child in the Google I/O app for the Google I/O animation. As I mentioned before, you can take these animations and you can manually control the progress. So Eero, who makes the mesh router system, started using Lottie for their setup for their routers. So here's an example where they actually loop individual sections of an animation while it's going through different phases of the setup. So while it's finding the other routers, while it's configuring the IP address, or configuring something else, they can create little segments of the animation and just have that repeat until it's done, and then it moves on to the next section. New York Times actually started using Lottie for static assets. This is actually not something that we'd considered when we released Lottie at first, because it's an animation library. But it turns out that it's actually minified JSON, it's super small, it's cross-platform, and you can dynamically change the colors. So here in New York Times, there's a night mode. They can actually use the same animation and change the color from light to dark. And you can get more advanced and change certain parts of an animation and get really fancy if you want. You can even use it for loaders, splash screens. There have even been studies that show that the more interesting a loading spinner is, the longer users will wait before bouncing. And so you can actually improve metrics just by like adding some little flourish to a loading spinner or something like that. It's also just JSON. And so we're experimenting with some projects where we'll be downloading these animations over the wire. They're really small, like 50K or 100K, for a fully featured full screen animation. So you can imagine booking a listing in San Francisco, and then on the confirmation page you see like some dots like transform into the Golden Gate Bridge, or maybe the skyline of New York City, or these three examples behind me. The community even built a website, lottiefiles.com. This is not maintained by us, but it is maintained by the community. Since they actually came out with it like the first week after we open sourced Lottie, but since then they've had over 100,000 downloads of animations across the website. There are over 400 animations you can just go and download and drop into your app. This is really great if you're you have a side project or something like that, or even you see something that would be useful for you. You can just use them from this website. But you can also use it for previewing animations or sharing them with a colleague. And so if you drop a JSON file onto lottiefiles.com, not only will it render right on the web page with body movement, but it creates a private link that you can send to your colleagues so they can either look at it on their computer, or there's even a QR code you can scan with that sample app, and it'll then download that JSON file and render it right on your phone. So without further ado, this is what Lottie can do. Let's actually learn a little bit about how it works, because it's like you have JSON and then you have an animation all of a sudden. Let's actually get deep and dirty and let's look at some Android APIs, because while building Lottie is quite interesting, kind of learning some of these parts of Android that you don't actually encounter day to day, talking about like MVP and MVVM and all these frameworks, but there's a lot more to Android than just that. And so let's actually take a deep dive and build an animation together. So this is what we're going to build. This is what you'll be able to see on your phone at the end if our live demo works, and you download the app. So in order to do that, we need to learn a little bit about languages. So obviously we all know English. This is why we're here. This is why you can understand what I'm saying right now. And I bet most of you also know Java, right? It has things like if and extends and classes. A common other language that people have started to talk about is Kotlin. And I knew I had to throw in a Kotlin slide. And generally, like most Kotlin involves happiness, excitement, and an exclamation mark. And like if you really know what you're doing, maybe 2 exclamation marks. Some languages don't even have words at all, right? Here's like if you're a layout designer, maybe you make magazines or newspapers. Your language might not even be words. It's just how does it look? Where are the boxes on the screen? And then these are the kinds of things you would send to someone else to convey the meaning. Well, animators have their own language, and it involves things like strokes and mattes and keyframes, scale and shapes. So these are the words that they're thinking about. These are the tools that they're going into After Effects and they're using and they're adding to their animations. But these don't always translate directly to how they're implemented under the hood. So engineers actually have their own language for animation. It involves things like affine transformation matrices and shaders, hardware layers, and Porter-Dove transfer modes. And so we get to talk about some of this fun stuff today. We're actually going to combine them and talk about the design side and the engineering side. So let's talk about animations, what they actually are. We know that there's going to be a language. We're going to have to learn a little bit about them. But an animation at a high level is really just a shape that changes over time. And once you understand that basic concept, those are the 3 building blocks that an entire animation is built off of. So let's talk about shapes. A shape, from an engineering perspective, is actually a list of Bezier curves. In fact, to break down what a Bezier curve is, let's take a look at this cloud. I'm going to zoom in a little bit. You might not be able to see it, but there are these like earwax colored things around it. Those are called control points and handles. What it actually is it's a list of segments of a shape. And each segment has a starting point, an ending point, and 2 control points. And so here are some examples where you can see the ends of that line. Those are the start points and end points. And then if you were to draw a line from the start point to control point 1, and then the end point to control point 2, you see it creates these 2 little handles, right? So this is all the information you need to describe a curve between 2 points. And when that curve will start tangential to that first control point and end tangential to the second one. And the longer the magnitude of that handle is, the more you can think of that curve being pulled in that direction by that control point. And so this is really the fundamental building block that anything that you see in Lottie is built off of. So again, let's build this cloud. The API that you use to build a shape is the path API. So we'll start, new path, we have nothing right now. We need to start somewhere, so we'll move to a point. Right? Again, we see nothing on the screen. All we've done is taken this like pointer and we've gone to -80, -5. Now let's draw a first curve. So we want to draw a cubic Bezier curve to another point. And so it takes 6 values. It remembers the previous point where you started, and then you add the 2 control points and the end point. These are the same values from the previous slide. And then you now have a curve. And again, this endpoint becomes the starting point of the next curve when you draw your next cubic Bezier. So we'll step through this one by one, and you can see as we step through this, the cloud starts to take shape. Let me close it at the end. So this is great. We now have a shape. But by itself, it doesn't really do anything. We need to make it visible. And to do that, we'll give it a fill. So a fill in After Effects is basically you take a shape and you want to fill it with a color. It's actually pretty easy to implement with the drawing APIs. You have Paint in Android, and you could just call paint.setColor, and then you draw a shape, and then it fills it in with that color. It's pretty great. Really handy. But fills in After Effects are actually a little bit more complicated than that. You might think initially that you have a shape and it has a property that is its fill. Well, these are actually 2 separate constructs in After Effects. So let's say we have something like this, right? They're actually, the fill and a shape are the same level of an API. They're both just contents. And they can't be children of each other. They're at the same level. So what's actually going on here? So After Effects starts at the bottom here. It's going to look at red. Red says, hey, I'm a fill. I draw shapes. I fill in shapes. So then it will walk up this tree, vertical, and it hits 50% blue. Says, no, I don't care about you. And then it hits this rectangle, and it says, okay, I'm going to draw you red. And then After Effects moves on to the next thing. It's at 50% blue now. And it says, hey, I also draw shapes. Then it's going to walk up the tree, and it's going to draw the rectangle again. So here, if we actually were to set up an animation like this, we'd actually get a purple square, because we draw a red square and then a 50% opaque blue square on top of it. If you were to move that 50% blue after the rectangle, you would only get red. That 50% blue would have no effect, because there would be no shapes above it to be drawn. So this is quite powerful, and it's important to understand this concept because we've added dynamic coloring to Lottie. And so you can actually change the color of a specific part of an animation. So here's an example where we can actually change the color of this pin specifically, but in order to do that, you need to target the fill itself, right? You might think like initially, like I want to make the pin red, and so through the API you say pin red, but what you actually need to do is target the fill that draws it. So this is great. So this is a fill. So fills also can be a little more complicated than that. You can make it a gradient, right? Lottie supports linear gradients as well as radial gradients, and they can be more complicated than just color A to color B. In fact, you can set arbitrary numbers of midpoints and stops. So here's an example of a gradient that goes from red to green to blue. If you were to set this up in After Effects, you would actually see that gradient in Lottie. But it might not be obvious how you would do that at first. So Paint has a set color method. It takes a color, but that's not enough information to convey a gradient. So you might look through the API, search for gradient. You might look for a set gradient API. It actually doesn't exist. It's not a thing. If you then look through the docs, you might find a class called linear gradient or radial gradient. And it's curious because there's no set gradient, but there is actually a set shader method on a paint. So what's a shader? A shader is a way that allows you to sort of create more like effects on an image, or create something that involves a lot of pixels really efficiently. And so in the case of a gradient, it's a kernel function that takes a pixel position, like an XY, and it gives you a color. And so you could apply this to an existing bitmap, or you could just use it to generate a gradient. And so the reason why it's set up this way is so that you can run it on the GPU like super parallelized, run it 1,000 times at once instead of iterating through the dimensions of the bitmap size that you're trying to create. It just shards it off to the GPU, and it gets all the pixel data back, and it puts it all together, and then you have a gradient. So this is how we do gradients in Lottie, and it allows us to do these more complex gradients with multiple colors as well. A stroke is very similar to a fill. Except that it just outlines it instead. It has a width. You can also set you can do the same thing with gradients. So you can have a gradient stroke. Creates sort of a strange effect, but it is useful sometimes. But strokes can also have something called a dash pattern. So a dash pattern is a fancy way of saying like you have a dashed line now. And so in this case, we use it to make the billboard of our animation look like it has one of those like show lights around it. And so for that, we use an API called dash path effect. Dash path effect takes an array of values and an offset. And so the values it's a repeating set of values where the first one is the length of a dash, and the second one is the length of the gap. And so if we set it to 2020, we'll have 20 pixels of a dash, 20 pixels of a gap. If you do 2040, then your gaps will be twice as long. You could do 200, 200, and then you'll see you have really long dashes, and then you can offset it, so you could have it spin around or something like that. And again, all these properties are animatable, and so they all assume, like Lottie assumes that any of these values can change over time. But we'll get to that in a second. In addition to dash patterns, you also have trim paths. And so that's how we achieve the fireworks here. If you were to zoom in on a firework, you'll see it's actually kind of like a star shape, but the firework is just that line, like you're only seeing one segment of that line at a time. And the start point and end point that is visible is what changes. But that whole path is actually there, just not drawn. So for that, we use an API called path measure. Path measure is super handy. You can give it a path, and then you can get properties like the path's length. This is really, really useful for things like calculating the start and end positions when you want to show maybe like 25 to 75% of a path. You can then use a path measure again after doing some calculations to figure out what segment you want. And it has the original path already. You give it a start and end position on it, and it'll give you a new path that you can draw that's only that segment. So that allows us to do these types of things. Masks are also quite interesting. So that's how we achieve the moon. If you don't recognize the moon, you're not crazy. It's only in this slide. It's not in the rest of the animation. But let's take a look at it a little bit more closely. So you have this moon, which is very creatively just a lot of dots. I guess that's what the moon looks like. But we want to take this whole big pattern and then turn it into a crescent shape. And so you see the first thing we do is it's like we punched out a circle, and then we almost did like an inverse punch to cut out that concave part. And so that's because there are two kinds of masks. A mask, just at a high level, is a shape that's like stuck to a layer that defines what part of that layer will be visible. And so first, we mask a circle. But then to cut things out, there's actually a subtractive mask that will basically invert the shape that you mask. And so we then offset a circle from the original one that we cut out, and then do a subtract mask, and then that cuts out the crescent part, or the concave part of the moon. There's a similar concept called a matte. Mattes and masks are pretty similar, except a mask is part of a layer. It's a shape that's part of a layer, whereas a matte is basically saying, I want you to draw this entire other layer. It can have its own masks, it can have its own mattes, it can have its own shapes and whatever you want, but it's basically saying take the alpha channel from this layer and overlay it on this other one. And so that's used in this particular case to make basically a window, so that this house, as it slides up, is only visible once it's above like this horizon looking thing. And so it actually, the house exists before it's visible, but it's just matted out. And so that's how we create this effect. And the key difference here of masks versus mattes is that a mask is part of a layer. It's attached to it. So if that layer moves around, that mask will also move around with it. Whereas a matte is a totally separate layer that just gets applied to it. And so that's why in this particular case we use a matte, because that window that the house is visible in doesn't move as the house moves. So how do we do this? Let's take a look at Canvas. There's this funny API called save layer. So we give it some bounds and a paint and save flags. Like, I don't know what any of this does, so we'll just call it, I guess, and then we'll draw some stuff. But nothing will show up. But then there's this other funny API called restore. We call that, and then we get what we drew back. But at this point, we've basically just wasted a bunch of CPU cycles and done a bunch of stuff we don't need, because we haven't done anything special. What actually happened here was we called save layer. All those drawing commands got redirected to an off-screen buffer. And then when we called restore, it uses this paint argument to this call and restores it back to the original layer. And so again, by itself, not super useful, but Paint has this really cool API called a transfer mode. And finally, it has good documentation in O. And if you go to the documentation for portrait of transfer modes, you can actually see, given these top two things, you might not be able to read it, but this red circle is called destination image, and the blue square is called source image. If you were to apply these different portrait of transform modes, you get these different effects. That's a sort of a combination of the two. And it turns out for doing mattes and masks, this destination in one, super useful. And we're going to actually step through it step by step. And so there's an API, of course, for it, portrait of transfer mode, and you can apply it to a paint. And all of the different transfer modes have an enum, or a constant that you can use, so you can choose which one you want. So let's actually step through an example. So we have this blue background already, and we want to draw this red star. My caveat, for the sake of the simplicity of the slides, is don't actually use a mask for something like this. That save and restore layer call is actually pretty expensive, and you should try to avoid using mattes and masks when you can, if you can achieve the same thing without it, because it actually has to redirect to an off-screen buffer and then copy everything back. If you're not using hardware acceleration, it's pretty slow. If you are, it's quite a bit faster, but it's still definitely ideal just use shapes if you can. But there are times where it's difficult to avoid using actual mattes and masks. The other thing is that it will understand the bounds of what you're drawing to, both for your original content and the mask and matte itself. And so it will only render to the off-screen buffer the intersection of the bounds of the content plus the mask. And so you can make your mask as small as possible, and then you can get some performance out of it that way. But anyways, let's draw this red star. So we're going to start just by calling save layer, just like we did before. Nothing special. Now all of our render calls will go to an off-screen buffer. So this off-screen buffer, we'll draw a red square. Again, I've simplified this for the purpose of the example. I don't actually recommend using a mask for something this simple, but it's going to help us illustrate what's actually going on. So we have this red square, and then we're going to call save layer again. It's like almost like buffering inception. We're like going like really deep into these layers here. We're actually in our second off-screen buffer now. And then on that layer, we're just going to draw a star, a black star. Nothing special about it. It actually doesn't matter what color we draw this, because this is our mask. It doesn't even really have that property in After Effects. But whatever we draw here will become the mask for what we just drew. So now we're going to call restore on the second off-screen buffer with that destination in porter-dove transfer mode, which will take that star and apply it to the red square we already drew. So now we have this red star on our first off-screen buffer. We then just call restore on that layer with nothing special, and now we have that red star on our main one. And so you might be wondering why we actually need both off-screen buffers, and that's because you might have many different layers in your animation already, and we don't want to apply the mask to everything we've already drawn. So we need to sort of move to a temporary buffer so that we only mask that current layer. Lottie also supports text. So there are actually two different ways of rendering text with body movement. If you go into the settings, you can export your animation text as glyphs. In that case, it'll actually basically render out the font of the text that's in your current animation as a shape. And then we can just render it as a shape, just like any other shape in Lottie. It's just a list of Bezier curves. But it's pretty useful. I mean, I think for simple things it works fine. But what about things like internationalization? Or if you want to do something like a score or the weather or a date or something like that. For that, uncheck the glyph one, and then you can actually tell Lottie where your fonts are saved, and it'll actually load the font, and it'll render it dynamically. There's also a text delegate you can set, and so it'll pass you back the text that was set in After Effects. You can essentially use that like a key. It'll give you text back, and then you're like, hey, use this text instead. It's called a text delegate. There's documentation online where you can learn more about it. And again, all the properties that Lottie normally supports are all animatable. So things like the text size, kerning, spacing, all kinds of stuff you can animate. You can make it bounce around and do all kinds of fun stuff. So cool. So now we can draw text, we can draw shapes, we can strokes. So like we can make a really nice static asset right now. But let's make them change. And so in order to do that, let's talk about something called a transform. A transform is a term that's actually in After Effects. You can actually see something called transform in the UI. And it's a list of things that you might want to change or animate, like position, scale, and rotation. This is not all of them, but it's what you use for most things in an animation. So let's say you want to make this red square go from the top left to the bottom right. Maybe you want to rotate it or scale it up or down. Well, there's this cool thing from linear algebra, if you guys remember linear algebra, called a matrix. Right? So here we have a vector. It has x and y. It turns out there's this like a special matrix that you can multiply that the original point to, that will translate it tx and ty. And I'm not going to go through the actual matrix multiplication. It's not that complicated, but if you basically you can assume that if you were to multiply these two matrices together, x prime y prime will equal x times tx and y times ty. Turns out that there's like a few of these special ones. If you want to rotate or scale something up and down, you just set elements 1 and 5 to scale x and scale y, and you'll actually get an independent scale in the x and y direction if you want. And then you can rotate it as well. And so again, these are things you can write out the math. It's not super complicated, but it works. You can even smash all of these together, and you can do them all at the same time. And it turns out that this is actually a really common thing done in graphics, which is why Android has an API called Matrix. And this isn't even like a generic Matrix API. This matrix that we just showed on the previous slide was an entire API built to do stuff like this. and it's the affine transformation matrix, which basically allows you to take any points and sort of map it to some other points. And so it has a bunch of APIs on it, like pre-translate, pre-rotate, pre-scale, and you can combine these and then apply it to a point, apply it to a canvas, apply it to a shape, and then you'll get a transform shape out of it. So as we're animating some of these shapes, this is how we apply those effects, just by passing a matrix down. One thing to note about the way the matrix works is that we take this matrix and we pass it down all the way from the parent layers all the way down to the children, all the way down to the shapes, and we accumulate these transforms over time as you're going down. And so instead of like transforming the canvas at each layer, we just keep going all the way down until the shape has one transform at the end. And the reason this is actually important is because when you scale things on a hardware accelerated canvas, Android won't anti-alias that hardware acceleration scale. And so if you were to scale something up a lot, turn on hardware acceleration, it would look pixelated if we didn't scale it only once at the end. Another thing that you can do to move shapes around is parent something to something else. So in this particular case, we use parenting to achieve a nice little bouncing effect on the doors and the windows of this house. I mean, parenting, you could probably achieve most of these effects without parenting. You can have two movement curves that are basically the same. Maybe like you notice here how the windows and the ceiling, there's just a little bit of an extra bounce at the end. It's a nice subtle touch. But it's really difficult to maintain an animation if you wanted to like change the timing of the house a little bit. You'd have to go in and change the windows and the door and the roof to kind of match everything. But wouldn't it be nice if you could just say, hey, door, you're attached to the house, and the windows, you're also attached to the house, like they kind of are in real life. And then all you have to do is add that little subtle movement at the end. So great. So now we have shapes, and now we make them move. Now let's make them move over time. So in order to do that, let's talk a little bit about an interpolator. So things in the real world move with an interpolation. I know Android, it used to be common to use an accelerate-decelerate interpolator, and then there were some slightly more physical-based interpolators that were added in Lollipop with material design. Well, it turns out in After Effects, it's very, very similar, except all the interpolators are sort of defined as a Bezier curve, just like the shapes, from 0, 0 to 1, 1. And there's actually an API in Android, Path Interpolator Compat, in which it assumes that 0, 0 to 1, 1 Bezier curve. And so then the only thing that's left are the two control points. And that's how you define the timing between t equals 0 and t equals 1. So this is what we use. This is how all the timing curves work in Lottie. There's just a bunch of path interpolators. And that allows us to achieve really nice, more like physical effects that match what you see in After Effects. Another thing is between colors. So you may have an animation that goes from black to white, but if we were to just linearly move between these colors, it wouldn't actually look supernatural to you. In fact, if we were to take this gradient from black to white and sort of chop it up based on how your eye would perceive the difference in color, and then sort of quantize it, it would look something more like this, where you see the darker colors are a little bit wider and the lighter colors are a little bit narrower. Well, if we were to then redistribute those and then sort of plot what that looks like, you'll get this thing called a transfer function, in which that's sort of its gamma equals like 1 over x to the 1 over 2.2, which is it's based on luminosity and sort of the way we perceive light. And so instead of linearly interpolating between two colors, we actually do this sort of gamma interpolation. And the effect is actually really nice. So here's an example it's less obvious from black to white, but in this case, we have red to blue. And if we just go linearly through RGB, you see in the middle, it's kind of this like muddy, like dark brown, like blackish color. But when we just do the same thing and go through the gamma transfer function instead, you get this like really even distribution from red to purple to blue, which is what you would naturally expect to see if you were to like draw it with a crayon or something. And then this is what After Effects does under the hood, and this is what we do on iOS as well. It's sort of similar for gradients. We do the same gamma interpolation, but unfortunately the gradient itself is immutable. So instead of, if we actually wanted to do a proper animation, we run the risk of doing a lot of object churn. right? Like this, like a gradient animation would be on the hot path, where we're re-rendering this frame every like 60 times a second to hit 60 FPS, and generating a new gradient every time. That's super expensive. So we break it down, and we basically quantize we round a little bit. We round these gradient animations to sort of quantized values that are like roughly like 30 FPS. I think you can configure the value. And then we generate like a hash code, essentially like a hash code key for this rounded value of the gradient, and then we cache them. So the first time you go through the animation, it'll generate a bunch of gradients, and then as it loops, it's just going to start reusing those gradients over and over again. And then we put all this together, and then we have these values, and they change over time, and that's called a keyframe. So a keyframe, it has a start value, it has an end value, a start frame, an end frame, and a time interpolator for how you get from the start value to the end value. And so at the end of the day, an animation is just a bunch of keyframes, where the value might be a shape, the value might be a position, it might be rotation, it might be a list of your gradient colors or anything like that. And so once you have all your keyframes, you just start walking through your keyframes, and you've built up this animation. So that's actually more or less how Lottie works in a nutshell. I mean, it's all open source. Feel free to browse through the code, but those are all the main building blocks that are required to actually build that entire city animation, and pretty much everything else that I showed before as well. You might be wondering, another common talk for this week is testing, right? We do actually do testing for Lottie. We do visual screenshot regression tests. And so we have both on the external repo, we have a bunch of tests, and it runs through them, and if anything, if even one pixel changes, we'll know. We also have an internal one where we have our own assets from our own app, but we also take animations, or we accept animations from any of you guys, where when we push a new update to Lottie, we don't want to break your apps. And so if you email us at lottie@airbnb.com, we can actually add your animations to our internal testing suite. And it'll never be open source. It's all private. It's internal. But we can actually guarantee that we're not going to break the rendering of your animation with a future Lottie update. It's pretty easy to use. So you install the body movement plugin, you hit render, gives you JSON. Pretty simple. You might be wondering though, if you're sitting through this talk and you're like, oh, this is great, but my designer doesn't use After Effects. Maybe they use Illustrator. So Illustrator can actually export to After Effects. You can more or less just drag your After Effects file drag your Illustrator file into After Effects, and it'll create a layer. There's one caveat, is that by default, it'll actually export, body movement will export that After Effects layer as a PNG. And then you've basically lost all of the benefits of Lottie. So all you have to do is right-click the layer, convert it to a shape layer, and then re-export it. And then it'll work great. Pretty much anything you can do with Illustrator will come in just fine to Lottie if you do this way. So that for any of you engineers, if you feel like you're getting a lot of PNGs from your designers, I've seen this happen many, many times. So keep an eye on that. Maybe they use Sketch. Google actually just came out with a Sketch to After Effects plugin. Super awesome. So you do need After Effects still, but you don't need to know how to use it. So you can just go straight through, and then this is great, for the static asset case, or for whatever other reason you might be using Sketch. And hopefully, if they're using the supported features of Lottie, it kind of just works. You can do it programmatically. You can just call set animation with an asset. You can give it a JSON object if you download it over the internet. You can even do it all from a layout file. There's attributes for everything as well. And in fact, one of the first PRs I did after merging Lottie was this one. And this was one of the happiest PRs I've ever merged in my entire life. I mean, literally in our app, the loading spinner that you saw before you even got the opportunity to log in was 90 PNGs playing on loop. On Jelly Bean, KitKat, on Android One devices. It was lovely. And now it's just a JSON file. But sometimes it doesn't work, This is a thing. It's like we're basically reverse engineering 20 years of After Effects on a little mobile device. And so, yeah, not everything is supported. You can do a lot with it, clearly, but on airbnb.io/Lottie, it's our documentation website, we have a whole table of supported features. And even still, there are a lot of features that we do support, that of which there are like 5 different ways of doing it within After Effects, and we support like the most common way, but some people still do it kind of an older way. that they could make it work if they just did it a different way. If you're still confused, just file an issue on GitHub. I'm pretty responsive there. You can also email them to me at lottie@airbnb.com. And we're not done yet, right? We're just getting started here. Like, also, if any of you want to contribute to Lottie, I'm more than happy to work with any of you if you're interested. But we're going to start working on things like, in addition to like building on top of this animation framework, to do things like dynamic properties. So you can have interactive animations where you can move things around. Maybe they can respond to states or like temperature of your house or something like that. And then, or like stateless drawables where you have switches and toggles and other kind of UI elements. There's also like a laundry list I could go on for like an entire other talk of like all the things we can do with Lottie going forward. But we're basically just getting started with this thing. So I don't know if any of you guys actually followed the instructions at the beginning to download this app, but if you did, there's a QR code on the screen that's as big as I could make it. If you open up the app, go to the animation viewer, there's a little QR code button. Just hit that, and you should be able to capture this thing. But basically, this is Lottie in a nutshell. I have some bullet points. I don't want to forget anything here. I have stickers. We're hiring. You can also reach me at Twitter, gpeel8. Also, coincidentally today, I don't know if you're familiar with Airbnb experiences. It's you can basically book a unique experience with a local host. We launched in New York today with 150 experiences, so check that out if you are bored. I'll hang around up here if you guys have any questions, but yeah, thank you.